says, show that alpha plus beta equals minus b over a and alpha beta equals c over a. So let's get started. Now, if alpha and beta are roots of a quadratic equation, it holds that the independent variable of that quadratic equation is equal to either alpha or beta. That is, if for example the independent variable is x, it means that x equals alpha. That is, since alpha is one of the roots, it means the independent variable x equals alpha or beta. So from this, it means we can actually form the quadratic equation whose roots are alpha and beta. Now to do so, we need to equate these individually. Hence, we have x being equals to alpha and x being equals to what? Beta. So at this point, we need to do transposition. Now by transposition, we have x to be equal to, x minus alpha being equal to 0, or x minus beta being equals to 0. Now, since these two expressions are equal to 0, we can form factors from this expression and equate it to 0. Hence, we have x minus alpha, x minus beta equals 0. Now, at this point, what we need to do here is to expand. Now, by expansion, we are going to multiply x by everything we have in the other bracket. Then we come back to multiply minus alpha by everything we have in the second bracket. So we have x, parentheses, x minus beta, minus alpha, parentheses, x minus beta equals 0. Now, let's multiply. By multiplication, we have x squared. X times minus beta gives minus beta x. Then minus alpha times x gives minus alpha x. Then minus alpha times minus beta, we have plus alpha beta equals 0. Now, if you look at this equation carefully, you would agree with me that there is something common between minus beta x and minus alpha x, and that is minus and x. Hence, we factorize that. Now, factoring that, we're going to have x squared minus parentheses. Now, to get what we're going to have in the parentheses, we need to divide the first term of what we are trying to consider by the minus. And remember, x is also common. So dividing this by minus x, you are going to be left with what? Beta. Now dividing minus alpha x by minus x, we're going to have plus alpha. Then we have plus alpha beta equals 0. Now, we can actually rearrange what we have in the parentheses since alpha comes before beta. Hence, we have x squared minus alpha plus beta, x plus alpha beta equals 0. So at this point, we have actually formed the equation whose roots are alpha and what? Beta. Now at this point, we call this our equation 1. Now we need to recall the model of quadratic equation, and that is recalling that the quadratic equation model is ax squared plus bx plus c equals 0. Now, from this, we need to transform this model such that it looks like our equation 1. Now, to do so, it means we need to divide this equation through by the coefficient of x squared, which is the leading coefficient. So, doing so, we are going to have, we have dividing through by a, which is the leading coefficient. Now, dividing that, we have a x squared all over a plus bx all over a plus c all over a being equals to 0 all over a. So a cancel out a here, we'll be left with x squared plus b over a x plus c over a equals 0. Now you would agree with me that what we have now actually looks similar to what we have as our equation 1. Hence, we call this equation 2. Now at this point, since we have similarities between equation 1 and equation 2, we need to compare the expressions we have in both equations so as to isolate the respective coefficients so as to show the requirements of the question. On that note, by comparison between equation 1 and 2, we're going to have, if you look at it very well, we have x squared, then we have the coefficient of x in equation 1 being equals to the coefficient of x in equation 2. Since what we have there are similar, so we have minus alpha plus beta being equals to b over a. Remember, we are comparing equation 1 and equation 2 so as to make necessary equations. Now from here, since we are looking for alpha plus beta, and we've already seen the limelight of alpha plus beta, but mere looking at the sign of alpha plus beta, we have a negative sign. Now we need to eliminate that. Now to do so, we multiply the whole equation by minus, or minus 1, so to say. So multiplying through by minus 1, multiplying through so we have minus 1 parenthesis alpha plus beta equals minus 1 parenthesis b over a. Now, when we multiply that, we have alpha plus beta to be equal to minus b over a. That's the first one. Now, we go back to the two equations again. We would actually see that the constants in equation 1 can actually be equated to the constants in equation 2, since the equations we have there are similar. Hence, we have alpha beta to be equal to c over a. Since the question here says that we should show that alpha plus beta equals minus b over a and alpha beta equals c over a, through this solution we have actually shown that alpha plus beta equals minus b over a and alpha beta equals c over a. So Q E D, that is quadratic demonstrandum, which shows that I have proven or shown what I am required to do. I believe this helps.